Hi guys, welcome back to the Tomb of Illumination. Flat Earth physics. We're discussing the expansion of our realm as you move south. People can't understand this stuff. That guy took the boys to Antarctica, had a thing on YouTube the other day, the final discussion, flat earth discussion or something or other, and he showed one of the flat earthers this map here of Australia, and then he showed them this picture of Australia and asked them which one was real, and the flat earther says that one. It just goes to show that these flat earthers aren't onto it. They don't know what they're doing. That image there in relation to arcs of longitude is the exact same image as this in regards to arcs of longitude. It's understanding the expansion of our realm from north to south and disbelieving the comedy of this. I mean, people believe they live on a ball. They're accepting that everything expands to the equator and then takes a bit of a rest on the way through the tropics, because it doesn't expand anymore through the tropics, and then gets to Capricorn, and then decides, oh, we'll shrink back now. Where does that come from? You've got to be completely bonkers. Most people don't think. But this is consistent. It expands southward equidistantly. Everything in the field expands. You, trees, land, whatever. Land's fixed. Terra firma is fixed, but everything on it expands in the field because everything is of the light. Walter Russell told us that. Electromagnetic ether. So even the Bible, it talks about it. In those days were giants, because the south, they're referring to the southern hemisphere, comes north and back again for seasonal change for the tropical year. You're not flying around the sun on a ball. No, the field shrinks in. The southern stars come north. You don't see them in the tropics overlaying the northern star till they get to the northern side of the tropics. Then there's the star overlays. This is the forming of the constellations as they're going around every day. But they move in declination, south to north and back again, 1 degree per day. It's all through the Bible, but no one can read the Bible. Trust me. So this is consistent, equidistantly, expanding out from the centre. So that image there is just the same as that, or it's just the same as a Mercator map. They're all the same. They all represent the same thing. It's a trinity there. You don't live on either one of them. They're models, basically. Although the Earth is flat, and it's realistic. So we're going to talk about one of my Patreons here, Dustin, talking to a new AI called Claude, and he's trying to get to the bottom of this expansion, trying to understand it, right? So this is questioned old Claude. If I'm driving around a racetrack filming the crowd, so I'm doing this racetrack, because this is basically the same as the ecliptic plane. It's a circular racetrack. Right in the centre is the black hole. The first horse on the track from the centre is the sun. Okay? And all the energy comes out of the centre, like a clock. All the energy is from the centre, governed by the centre. So he's got the most energy. And they're trying to tell you all the background stars are quicker than this guy here on the inside track. It's comedy, mate. I've explained. The sun is the quickest. Okay? Even though on that Duffy show, I cocked up and went and said what everyone thinks. The stars are quicker. So just if you've seen that show, just bear in mind, I meant to say the sun is quicker than the stars. And I've explained it plenty of times. If people can't get it, what can you do? So here's the racetrack, and he's talking about these two size tracks here. Now, so he's filming the crowd, and I'm driving fast enough to travel 360 degrees in a circle that is 1 mile in 1 minute. Will I feel like I'm going the same speed if I travelled 360 degrees in 1 minute but travelled a 1.5 mile circuit? So he's got the two circuits here and he's doing them in the same time. So obviously anyone with half a brain knows that he's going to have to be moving a lot quicker out here, right? Okay. So bear that in mind. And the answer is no, you won't feel like you're going the same speed. And they give a few reasons here. And one of them here is they go on about what you'll feel in linear speed centripetal acceleration. I'm not understanding that centripetal acceleration, because if you're racing around a racetrack in a car, that car's going to want to be centrifugal as a weight force outwards. If you're running around a circle, a small circle, you're only got centripetal, some sort of centripetal appearance, because you're finding your balance. So I don't know what they mean pulling. There's no centripetal pull. Anyway, so it goes on to the next. So that answer was no, wasn't it? No. Obviously he's going quicker here when he's looking at the crowd out here. So it goes on to the next question. Okay, so using the same context, if I was watching the crowd go by, so I'll put a cross here now, and this says fixed, but using the same sort of scenario, he's watching the crowd go by. Would the crowd move by my field of vision quicker on the larger circle, even though they're both a 360 degree circle in the same amount of time? Okay, if I was watching the crowd go by, would the crowd move by my field of vision quicker on the larger circle? So he's out here, still going fast, and he's asking, are these guys going to sort of appear to go quicker past him rather than quicker on this inside track? And the answer is yes. These people would appear to go faster, because we've already done that scenario, but in reverse, I think, haven't we? Where we know he's going faster here, so he's going to zoom past them quicker. Now, hang on. Yes, yeah. Okay, if I'm watching the crowd go by, would the crowd move by my field of vision quicker on the larger circle, even though they're both a 360 degree circle in the same amount of time? Yeah, well, yeah. It's like I just said, it's just a reverse scenario. Okay? They give all the answers as to why and all that. And then it comes down to the third question. Thank you. My last question is, using the same context, if there was only one person in the crowd and the person was 2 miles from the centre of the tracks, if there was only one person in the crowd and the person was 2 miles from the centre of both tracks. Okay, so it's 2 miles to there, okay? No matter what size track you're on, is 2 miles from the centre of both tracks, he's saying, right in there. It's the black hole, you see. And I measured how quickly that person moved across my field of vision. Would that person move noticeably faster while I was on the 1 mile circular track or the 1.5 circular track? Granted, I will only be able to see the person for about half of the time, but that is the time I'm referring to, when I can see that person as I drive by them. But back to there again we go. Okay, my last question. In using this context, if there was only one person in the crowd and the person was 2 miles from the centre of the track, and I measured how quickly that person moved across my field of vision, would that person move noticeably faster while I was on the 1 mile circle track? Okay, Okay, so there's one person. Get rid of these people here. And he's zoomed by, and he's zoomed by. So this is how it would work out too. See, this that short amount of time to get around his thing in a minute, and that stretches out for his minute. Okay, so you're there and you're there. And this guy zooms by. Okay? Think about it. Great question. This is a fascinating scenario because now the person is at a fixed distance from the centre, regardless of which track you're on. The person 2 miles from the centre, this dude out here, would move across your field of vision at exactly the same angular speed, whether you're on the 1 mile or 1.5 mile track. Amazing, isn't it? The key insight. You completed 360 degree in 1 minute on both tracks. The person is stationary at the 2 mile from centre. Your angular position changes at 6 degrees a second on both tracks. Therefore, the person's position relative to your angular view changes at 6 degrees a second on both tracks. What you'd observe, the person would sweep across your field of vision at the same rate in both cases. If your field of vision spans, say, through blah blah blah. Anyway, now that's fascinating, isn't it? You've got to realise in this setup here, this realm we're in, you've got your personal arc of horizon. So whether the guy's in here or in here, he's seeing the sky around him just the same as this guy, the same dimensions, equidistantly as this guy. You know, they're both got this equal distant arc of horizon. But he's smaller back here, and this guy's bigger. So as you move south, you're bigger and bigger and bigger, and the field is expanding, everything's expanding, so it's making everything equal. No matter where you are, you're equal. It's a fixed position, fixed. All the celestial bodies are seen in your arc of horizon. It's to do with your pupils, and there's a parallel connection because you've got your lenses of your eyes, haven't you? You only see so far. It's all there. There's no other depth to consider. It's there. Okay. Even though there is all this depth, but it's like magical because it's like Ken Wheeler's magical depth when he puts the LEDs around the ferrocell and shows all this 3D depth underneath the magnet. Where'd that come from? It's not really there. You look down, there's all this depth, but there's nothing there. It's not there. It's a flat plane, but that's magnetism for you, see? It's all illuminated from the sun. So we're in this realm illuminated from the sun. It's not actually there. Turn the sun off, everything disappears. People can't get their head around that one. So there you have it, the expansion. It'd be good if I could post that so you go over it yourself, but you want to, if you really want to think deep, go talk to GTP or any of those AI things and figure this out. So if it's like the clock, you see, so it works from the middle, center, the clock. But the clock arm, I'm not speeding up, it's just constant all the way across that 10, 15 degrees, whatever you want to call it. Okay? So you're thinking out here it's going to have to go a lot faster. But the sun governs time, and he hasn't sped up. It's still a consistent speed all the way, right? And if you've expanded with this larger field, it's just like a Gleason map. It's all parallel. This is I'm not sorry, a Mercator map. All the arcs of longitude are just all parallel. That's why they've designed that map, to show you it's all consistent. And then they go and come up with a globe and say, oh no, you use this geodesic BS. It's all lies. When you work out the sun's the timekeeper. He governs the time and distance. Because we associate it with the time it takes the sun to get over our arc of horizon. 180 degrees, how long does it take? So they work on 12 hours. Check out my earlier videos. And it's all based on this nautical miles, because it's the curvature. Okay? And inside the realm here, if we were to travel from A to B, we're using a compass, the field curves. It's equal curving like this. It's curves. There's the curves. It's the southern hemisphere. It's curves in here too. So it's coming out of the centre. So it's all consistent. It's not speed. The sun isn't speeding up out here. So you see the sun image. The sun's image is anywhere down the clock arm. At that particular moment in time. It's all relative to the observer in his, wherever he is, no matter what latitude. If he's out here, he's seen the sun here in his arc of horizon. This guy's seeing it here, all the way through like this. This is why the Egyptians state. It's fact. They're not stupid. The sun is in many places, but only seen in one. They're not stupid. Modern man is stupid. It's all consistent. Because it's consistent, you expand with the field. That's why they came up with the Mercator map, and everything is all parallel. All arcs of longitude are parallel. And that's a good representation of the size of the continents and that. But looking down as a whole, a planned view, you have to understand this. You have to understand the expansion. That distance from there is exactly the same distance as on there, and the exact same distance on the globe. Okay? I'm trying to go through more of that, but when I try to explain it, I get lost myself. I was hoping to explain it, but I mean, I've sat down there without the camera on me, I can think deeply and it all comes to me, but when I try to explain it using my mouth, it doesn't work too well. So understand this. So you got to understand the system, looking down on the earth, is pretty much the same as the ecliptic plane. You got this big round ecliptic plane up here, and all the planets are on there. Right in the centre of the black hole. It's the Milky Way, two ends of the Milky Way. And the sun is right here. Then you got the planets. All the planets. So you got planets. Okay? But everybody sees them all equally, only from this arc of horizon. You don't calculate anything. Well, you do. You've got to understand that's your arc. That's relative to you. But with celestial navigation, the calculations, do take the star to where it actually is in our toroidal field. Because you're a sextant reading of a star, let's say you got 30 degrees. Well, they want to know what makes up to your 90, what takes you to there, which is 60 degrees. You times it by 60 nautical miles, that gives you that point here. That all works in together to work out the diameter of the Earth, because this is 10,800 nautical miles. Two of those is 21,600. What do they tell you the circumference of the Earth is? 21,639. You don't have to think you live on a spinning ball, okay? understand this. I didn't go deep into what I was trying to do there, but I hope you got the gist of things. Okay? Thanks for watching. Cheers.